Hello and welcome to Minggu Sains Negara Forum virtual event. We hope that everyone is having a fantastic day. Allow me to introduce our group. We are from Center for Intelligence Signal and Imaging Research from Universiti Teknologi PETRONAS, and it is recognized as one of the MOHI High Center of Excellence in Neuroimaging. So let's go through the agenda for today. So first we have the introductions to neurotechnology, followed by neurotechnology demonstration video, which we have mind control drone, neurofeedback brain trainer, and lastly is about breathing technique. And then we have a quiz. And last but not least, we're going to meet the experts of their respective field, which we have here is Professor Dato Dr. Jafri Malim Abdullah is from Universiti Sains Malaysia. And the next one is we have Professor Dr. Esther Gunaseli from UniKL Royal College of Medicine. And last but not least, we have Associate Professor Dr. Nasrin Badruddin from Universiti Teknologi Petronas. So before we start, we're going to show you an introduction video from our University Technology Petronas, as well as the introduction video on neurotechnology, where in this video, we're going to talk about the definition of neurotechnology and why we need neurotechnology and the example of neurotechnology application. Let's take a look at the video.
To those of you who have come in search of answers, seeking inspiration and looking to achieve your aspiration, this is the place where you will learn to find the answers, where you will be motivated to discover your inspiration, where you will be propelled to realize your aspirations. With today's global challenges, the role of the engineer, the scientist, and the technologist is transformed from being the technical innovator into being the agent of global change. Our world-class resources and faculties, our cutting-edge facilities, our global partnerships with leading universities, our strong network with industry for internships and job placements, our worldwide research collaboration. These are the inspirations and the opportunities at UTP. Here, we nurture the analytical skills and intellectual capabilities of all who walk the UTP path. Here we culture the ethics and the attitudes that will shine in the real world. Here we expose ourselves to what it truly means to be human, to be a valuable part of society, to be the empowered people, the game changers who will light up the path towards a better world and change lives for the better. At UTP, the torch is firmly in your hands. So hold it up high and let us together light it and let it burn bright. Join us to seek inspiration and achieve your aspiration towards global prominence.
Neurotechnology is any technology that allows us to understand, improve or repair and connecting computer with the brain. One example is neuroimaging technology. It allows researchers and clinicians to visualize the brain. The two most popular examples of this technology are electrophysiological and metabolic neuroimaging. Electrophysiological neuroimaging directly measures electrical activity of brain's neurons, such as electroencephalography (EEG) and magnoencephalography (MEG). Electroencephalography records brain's electrical activity, while magnoencephalography records magnetic fields produced by brain's electrical activity. Metabolic neuroimaging indirectly measures brain activity. Example includes functional magnetic resonance imaging, positron emission tomography (PET), and functional near-infrared spectroscopy (FNIRS). These technologies use blood oxygenation levels, emissions of radioactive chemicals in bloodstream, and absorption of infrared light by hemoglobin, respectively. Another example is neuromodulation, or neurostimulation technology. It is a technology that lets us modulate, or stimulate our brain activity. For instance, if your brain behaves unwantedly like depression, epileptic etc., you could, theoretically, stimulate it with electricity of a certain, controlled frequency, to normalize its behavior. Thought input computing, or brain-computer interfaces technology, is a type of neurotechnology that connect computer with the brain. It is a technology of controlling a computer with your brain. Conventionally, if you have your intentions in your brain, there is a keyboard and a mouse, as a middleman between you and your computer. You tell the keyboard what you want to do, and the keyboard tells the computer your intentions. With the new upcoming consumer technology, that no longer require a keyboard or a mouse, or even a voice activation, like heads-up display of augmented reality, this requires a novel method of communicating our intentions to these devices. With thought computing technology, you can think of something, and your intention is executed on the computer, directly with no middlemen. Why we need neurotechnology is, first, to save lives. Neurotechnology disorder cause approximately 9 million deaths every year, and it is the second leading cause of death, after cardiovascular disease. Almost everyone has neurological problems over time like memory loss, depression, anxiety, hearing loss, insomnia, addiction, blindness, extreme pain, strokes, paralysis, seizures and brain damage, Parkinson's, Alzheimer's, epilepsy etc. So we need a generalized brain device that is reliable and affordable.
Number 2 is, we really do not understand the brain at all. Professor Jeff Lichtman, from Harvard University, famously said that, if everything you need to know about the brain is a mile, how far have we walked in this mile? 3 inches. It is kind of sad thing to think about, but the bright is that, we can use technology to go farther in this mile, and understand the brain better. There are some unsolved neuroscience problems. For example, in disease, what are the causes of neurological disorders such as Parkinson's and Alzheimer's? In human body movement, how are our movements so fine and controlled if our motor nerve impulses are so noisy and unpredictable? And in cognition, what is the neural basis of decision making? These are some of the questions that neuroscientists having hard time to answer it very well. Lastly, why we need neurotechnology is because we need to enhance our abilities. It is called transhuman. It is an idea that humans can be enhanced with technology. The truth is, human is having all sort of problems, like difficulty in sleeping, hard to focus after an hour, and get tired easily. So, the goal of transhumanism is, how can we use neurotechnology to enhance our abilities, and avoid these problems? In this part, we'll look at some of the examples of neurotechnology application, device control, and human enhancement. In device control, we have neuroprosthetics, where if someone loses an arm and they have a prosthetic arm, they can control that arm with their thought, i.e., motor imagery.
Enhancement. Humans have a lot of problems. We get tired, we get hungry, we get sleepy. The idea is, can we use neurotechnology to enhance us? In terms of sports, there is a company by the name of Halo, and they make electrode headphone that, based on their claim, can increase strength, endurance, and muscle memory. Those electrodes apply direct current with a certain frequency to your motor cortex, and stimulates the motor cortex to enhance your motor abilities. They were being used by the Golden State Warriors, a U.S. basketball team, for a period of time. For productivity, there is a company called Neurosity. They produce a headset to assist with focus and concentration. In terms of memory, there is a company called Hum. They basically develop a forehead patch that simulate theta waves, objectively to expand memory, by apply alternating current to your prefrontal cortex. For sleep, a company called Dream, they provide a sleep report, based on electroencephalography cap that you wear at night. For meditation, there is a company called Muse, developing an electroencephalography headset that assists with meditation by playing rainforest sounds, based on how calm you are through assessing the electroencephalography signal from your brain. There is a company by the name of Neuralink, an advanced brain-computer interface that invasively insert an ultra-thin probe into the brain to get a high resolution and high precision brain signal with the goal of transhumanism.
In brain imaging, UTP's researchers had developed an automated system to describe how different brain areas are connected, called Brain Navi. Brain Navi is used in brain injury diagnosis and rehabilitation monitoring. Brain Navi main application is to assist clinician in identifying suitable rehabilitation program for different traumatic brain injury patients. Brain Navi allows more optimized rehabilitation program than conventional practice, and ensure the clinical intervention is timely. In fatigue management system, researchers at UTP had developed a non-invasive measurement system based on near-infrared spectroscopy for mental stress. The base technology was developed to differentiate schizophrenia, bipolar disorder, and depression. Fatigue is the most critical accident risk in oil and gas construction.
Neurotech is recognized as one of the socio-economics innovation drivers required to transform Malaysia into a knowledge-intensive economy and shift Malaysia up the global innovation value chain.
Academy of Sciences Malaysia under Ministry of Science, Technology and Innovation had identified neurotechnology as technology drivers to transform Malaysia into a knowledge-intensive economy by design. We are going to look at some of the case study of how neurotechnology combined with other science and technology drivers can be utilized to develop the next generation technologies. 1. Neurotechnology combined with 5G or 6G, sensor technology and bioscience technology to develop 5G collars for real-time farm animal health and behavior tracking. 2. Neurotechnology combined with cybersecurity and encryption and bioscience technology enhanced security controls in highly connected farming. 3. Neurotechnology combined with 5G or 6G, advanced intelligence systems, cybersecurity and encryption, augmented analytics and data discovery, and bioscience technology to develop automated precision farming, for instance machine-to-machine communication via 6G network. 4. Neurotechnology combined with advanced intelligence systems in bioscience technology to develop brain-computer interfaces for swarm drone control for more efficient precision farming. 5. Neurotechnology combined with sensor technology, augmented analytics and data discovery and bioscience to develop real-time multimodal data collection and discovery via advanced drone or biosensors. 6. Neurotechnology combined with advanced technology systems and augmented analytics and data discovery to develop automated viral genetic structure prediction and analysis. 7. Neurotechnology combined with sensor technology, advanced intelligence systems, cybersecurity and encryption, augmented analytics and data discovery and blockchain to develop intelligent contact tracing and pandemic monitoring systems using swarm technology and network analysis. 8. Neurotechnology combined with advanced intelligence systems and augmented analytics and encryption to develop algorithms to monitor news outlets and online media platforms to predict infection spread and future infected cities during early stages of the pandemic. 9. Neurotechnology combined with 5G or 6G, sensor technology and advanced intelligence systems to develop 5G thermal imaging equipped drone swarms for surveillance and movement control. 10. Neurotechnology combined with advanced intelligence systems and augmented analytics and data discovery to develop demand forecasting for inventory and supply chain management using predictive analytics. 11. Neurotechnology combined with 5G or 6G, sensor technology, cybersecurity and encryption, and augmented analytics and data discovery to develop encrypted tracking of student bio and neurometrics for early identification of mental health stress. 12. Neurotechnology combined with 5G or 6G, sensor technology, advanced intelligence systems, and augmented analytics and data discovery to develop cloud-based computer vision systems and deep learning algorithms for automated wildlife species monitoring. 13. Neurotechnology combined with bioscience technology to develop next-generation antidotes for neurotoxins in biological and chemical warfare. 14. Neurotechnology combined with 5G or 6G, sensor technology, advanced intelligence systems and cybersecurity and encryption to develop brain-computer interface controlled swarm drones for high-level and complex military tasks. 15. Neurotechnology combined with advanced intelligence systems and augmented analytics and data discovery to develop machine learning algorithms to predict future disease outbreaks for early mobilization of resource supply security measures. 16. Neurotechnology combined with advanced intelligence systems and augmented analytics and data discovery to evaluate the environmental impact of ecotourism using machine learning algorithms.
In summary, neurotechnology is any technology that can help us to understand our brain, which is the most complex organ that we have. It's also included any technology that allows us to do stuff to, or with the brain, like neuromodulation and thought input computing, respectively. With the development and advancement of neurotechnology, it is indeed an exciting future.
3, 2, 1.
Welcome back. So thank you for joining us to this session. So next we are going to have a demonstration videos. The first we're going to introduce our first mind control drone, which is invented by our group. And in this video, you will learn about the principle of the drone, the system architecture, and also we're going to demo you on the mind control drone live in action. So let's take a look at the video.
Introducing UTP First Mind Control Drone. Mind Control Drone is a brain-computer interface technology that uses thought computing to control drone locomotion. Normally, human movement intentions are sent to drone through a drone's hand controller. Alternatively, in mind control drone, user's intention is directly sent to the drone by reading user's brain signal. In this configuration, user's movement intention will be sent directly to the drone by passing user's hand. This should make, theoretically, the communication between user and the drone become more effective. Though, there is still a long way to reach an effective brain-computer interaction, this technology that will be shown today is a working concept and in a right direction. Here, we will explain the principle that make mind-controlled drone possible. Specifically, we employed evoked response brain-computer interface, which also called event-related potential, or ERP-BCI. ERP-BCI are a general class of brain-computer interface, which rely on detecting the brain response to known external stimulation. This type of BCI is one of the most successful BCI types. Now, we will look at the mind-controlled drone architecture to better understand the technology behind the mind-controlled drone. To briefly describe this schematic, the aim of a BCI in general is to control an output device, in this case a drone, with our thoughts. In this specific case, we control the drone by selecting actions performed as flickering virtual buttons on a computer screen. The presentation screen displays a set of control options to the user. The control options include move down, move up, move forward, move backward, bend left, bend right, rotate left, rotate right. Each of the options displayed to the user then flickers, with a given unique flicker sequence with different options getting bright and dark at given times. The user concentrates to this presented stimulus. The user's brain response to the presented stimulus is measured by EEG due to the user focus on their target option or stimulus. This EEG signal contains information on the flicker sequence of the target option. The recognition system uses the measured EEG and the known stimulus sequence to generate predictions probability of different options being the user's target option. Finally, output generates the desired output for option with the highest probability being the user's selected option. Now, we will look at the mind-controlled
So next, we have a neurofeedback brain trainers video. So in this video, you will know about neurofeedbacks, so when it's used and how it works and also what to expect. So let's take a look at the video.
Meet Rodney, a postdoctoral researcher at the Center for Intelligent Signal and Imaging Research, UTP. Like others, due to the COVID-19 pandemic, he is working remotely from home. While many people regard working from home as a goal for overall work-life balance, those who find themselves actually doing their work from home report higher levels of stress according to United Nations report in 2017. This news may come as a shock to many people who may consider a work-from-home lifestyle to be one that's less stressful and marked with more personal freedom. While these stressors may not be the same as long commute times, toxic coworker interactions, or the feeling of never being alone, they still take a toll. Here are some of the common sources of stress that many work-at-homers faces: communication issues and being out of the loop, loneliness and lack of human interaction, bad health habit by regularly skipping morning meals and at time even lunch. If we bottle up our emotions, they don't just go away. Emotions will stay down until we physically can't contain them anymore, then they'll burst out fiercer than before. And it won't just be that one feeling, it will be everything else that's been thrown on top of it since. When it explodes, you do things you regret. Rodney's wife advised him to meet a psychologist and seek help. The next day, Rodney set up an appointment with a psychologist. Although he feels a bit nervous and embarrassed to ask for help, he gathers all his courage, and hopefully, he would not regret his decision.
Hi, Dr. Amy. I am feeling a bit down lately after I started working from home. I think because there is a lot of distraction and I could not focus. At time, I do feel that I work too hard but underappreciated. Please help me, doctor.
I see. I would suggest to you to undergo a neurofeedback session. I will explain to you first what it is and how it's work. After that, you can decide for yourself. Neurofeedback is a therapeutic intervention that provides immediate feedback from a computer-based program that assesses a subject's brainwave activity. Electrodes are applied to the scalp and brain waves are recorded. These electrical activity of the brain is also known as electroencephalogram, or in short, EEG. Neurofeedback is not considered a cure, but rather a method of managing or regulating the workings of the brain, so it functions in a healthier manner. This is achieved by repeated training sessions using a computerized neurofeedback program that teaches your central nervous system to reorganize and regulate brain wave frequencies. Now, let us have a look at the demo for the neurofeedback session using the brain trainer. Fascinating. Now, I wonder what condition can neurofeedback help? Neurofeedback therapy typically consists of once-a-week sessions for an average of 20 weeks. Some people need fewer sessions, while others require more. Neurofeedback helps improves brain function. The program will direct your brainwave activity toward more desirable and controlled patterns. You will get immediate feedback from the program when your brainwave patterns improve. Between sessions, you should notice changes in stress, sleep patterns, or mental clarity. After listening to Dr. Amy's explanation about neurofeedback, what it can do and what it could not, Rodney is now excited to embark on the neurofeedback program. Look how happy Rodney has become. Now, he can regulate his stress better and his life is improving. Thank you, neurofeedback.
So next, we're going to show you a breathing exercise video. So it is actually based on an ancient yogic technique called pranayama, which helps practitioners gain control over their breathing. So let's take a look at the video.
Sometimes, the brain goes in overdrive, especially when you are fearful and nervous, say, during an interview, meeting, perform on stage, or stumbled upon your crush. There are physiological changes during stress. During this time, there are changes in brain electrical activity, such as decreased and increased in alpha and beta power, increase in heart rate as well as excessive sweating. At this time, it is important for you to take deep breaths so that you can regain control of yourself. This is when the 4, 7, 8 breathing technique become handy. Imagine there is a balloon under your lungs, and every time you breathe in, the balloon gets bigger, and then you prick the balloon and let the air get out slowly. The way you do this exercise is to breathe in quietly through the nose for 4 seconds. Hold the breath for a count of 7 seconds. And finally exhale forcefully through the mouth and making a whoosh sound for 8 seconds. Repeat the cycle up to 4 times. Now, let us do the exercise together. Breath in, 1, 2, 3, 4 and hold. 1, 2, 3, 4, 5, 6, 7 and breath out. 1, 2, 3, 4, 5, 6, 7, 8 and we repeat. Breath in, 1, 2, 3, 4 and hold. 1, 2, 3, 4, 5, 6, 7 and breath out. 1, 2, 3, 4, 5, 6, 7, 8 and we repeat. Breath in, 1, 2, 3, 4 and hold. 1, 2, 3, 4, 5, 6, 7 and breath out. 1, 2, 3, 4, 5, 6, 7, 8 and we repeat. Breath in, 1, 2, 3, 4 and hold. 1, 2, 3, 4, 5, 6, 7 and breath out. 1, 2, 3, 4, 5, 6, 7, 8. Next time, when you do on your own, you can slowly increase from 4 cycle to more cycle. Thank you. I hope you enjoy watching this video.
So welcome back everyone. I hope that everyone enjoy and have gained some knowledge about our topic today, which is on neurotechnology. So let's put it to test and play some quiz, shall we? So in this quiz, there are 3 levels. The first one is about fun fact about brain. And the level 2, we have a question about brain modalities. And the third level is about neurotechnology. and each question is given 10 seconds to answer. So how to participate, you ask me, is very easy. You just need to scan the QR code that appears on your screen, or you can enter by log in to classtime.com and put it the session code that appear on your screen. So just to inform you that the first question is about your contact information. So this is for us to contact the winners. So there will be prizes to top 3 winners, but we only going to announce it by at the end of the forum session. So you have to stay tuned after the end of the sessions to know whether you are the winners or not. So I hope that we have participants. So everyone, you may join the quiz. We're gonna wait about few minutes for you to participate by logging to classtime.com, or you can also scan the QR code that appears on your screen to enter the quiz. The questions is about our brain, about neurotechnology, which we have about brain modalities, neurotechnology, and also fun fact on the brain. So we're gonna wait for a while for everyone to participate our quiz session on classtime.com before we're going to start our first question. So we have another 1 minute for everyone to join in and participate our quiz session. And again, I would like to remind you that please scan the QR code that appears on your screen. And also you can also participate by logging to classtime.com and enter the code that we provide on your screen. I think we're ready now. Okay, let's start our quiz session. So the first level is about fun fact about the brain. And the first, oh, okay. Okay, the first question is about your information. So just to inform you that this information is for organizer to contact the winners later on, right after the end of the session of the forum. So if everyone's ready, we can start the first question. Okay. Okay, let's start our first question. So, what is the average weight of an adult male brain? You have 10 seconds to answer. Okay, time's up. So, the answer is 1.3 kilogram. Moving on to the next question. The human brain has 100 billion neurons at birth. So, is it true or false? You have 10 seconds to answer. Okay, time's up. We're going to the next question. Oh, okay, the answer is true. Human brain has 100 billion neurons at birth. So the next question is about 75% of the brain is composed of, you have 10 seconds to answer. Time's up. So the answer is water. Next question is, the adult brain gets smaller as we get older. Is it yes or no? You have 10 seconds to answer. Okay, okay, time's up. So the answer is yes. Moving on to the next question. Is the brain asleep when we are sleeping? You have 10 seconds to answer. Okay, time's up. So the answer is no. Next question. How many layers of human head and what are they? You have 10 seconds to answer. 5 more seconds. Okay, the answer is scalp, skull, and brain. Moving on to the next question. The brain is composed of cerebrum, cerebellum, and brainstem. Which of the following is a function of cerebellum? You have 10 seconds to answer. 5 more seconds. Time's up. So the answer is balance and coordination. Moving on to the next question. What are the functions of brainstem? You have 10 seconds to answer. 5 more seconds. Oh, okay. Answer dah keluar. Okay, the answer is breathing, heart rate, body temperature, and digestion. Moving on to the next question. The cerebrum is divided into two halves, the right and left hemispheres. Each side of your brain contains four lobes. Which brain lobes primarily responsible for vision? You have 10 seconds to answer. 5 seconds to answer. So the answer is occipital lobe. Moving on to the next question. Gray matter consists mainly neuron cell bodies from which nerve impulses originate. Which statement is true about gray matter? You have 10 seconds to answer. Five more seconds to answer. Okay, the answer is it processes information. So next question is on the brain modalities. So the question is, brain activities can be measured using various imaging modalities. Which of the following is not a brain imaging modalities? You have 10 seconds to answer. Five more seconds. Okay, the answer is transcutaneous electrical nerve stimulations. So next question is, which type of brain scan uses X-ray? You have 10 seconds to answer. Five more seconds. So the answer is CT scan. Moving on to the next question. Which neuroimaging method helps provide information about brain function by monitoring oxygen levels in the blood flow? You have 10 seconds to answer. Five more seconds. So we're gonna have the last question for the quiz. Or the question, the answer is fMRI. So we're going to move on to our last questions for the quiz for today. Which brain scan involve injection of form of radioactive glucose into the body? You have 10 seconds to answer. Okay. Okay. Sorry for the technical issue. So that's all we have for our quiz for today. So we're going to announce the winner at the end of the session, tentatively around 1 p.m. later on. So you're gonna have to stay tuned to know whether you're eligible for the prizes or not. So next we're going to have a video corporate from the AELB. Let's take a look at the video.
In the line with the nation's effort to enhance economic growth and social development, the use of nuclear technology has also increased rapidly in many countries, including Malaysia. Atomic Energy Licensing Board (AELB) is the regulatory body responsible for regulating the use of atomic energy in Malaysia. This includes evaluation, licensing, and regulating the use of atomic energy and strategic items in accordance with the Atomic Energy Licensing Act 1984 and the Strategic Trade Act 2010. These acts are also enacted conforming to the international standards as prescribed by the International Atomic Energy Agency (IAEA). AELB plays a vital role in the installation of nuclear facilities, including license evaluation and verification. AELB is the only qualified authority that certified the Radiation Protection Officers (RPO) in the country. Under the provisions of Act 304, AELB is authorized to conduct inspections and enforcement of atomic energy activities. Failure to comply will result in the suspension and revocation of licenses, and suitable penalties will be imposed. Atomic energy application comes with unidentified risks. Thus, AELB is vigilant in responding to any type of radiological incident or nuclear security event. Therefore, Qualified Nuclear Response Team (NRT) is established and remain prepared to deal with any situation. AELB also provides a variety of nuclear and radiation technical support through radiological monitoring and environmental sampling activities. Our expertise is recognized both at national and international level. AELB's experienced officers are continuously invited as experts to share best practices in various areas, especially in 3S aspects, which is safety, security, and safeguards. We are also proud to be recognized as the only Nuclear Security Support Center, NSSC, in this region by IAEA that can provide best practices in the development, implementation, and empowerment of national nuclear security capabilities alongside other IAEA member states worldwide.
Welcome back, everyone. So moving on to our next activities, which is forum session. So I will pass the floor to our moderator for forum session today, Associate Professor Dr. Tang Ton Boon. The floor is yours, Doctor.
Good afternoon, everyone. Thanks, Shafiq. I hope that you have enjoyed our sessions so far. In these coming hours, we have lined up three very exciting talks. I hope that you will enjoy that. We have three very prominent scientists from Malaysia. First to come up, we have Professor Dr. Jafri Malin Abdullah. This is no strangers to us. He's a strong advocate for neurotechnologies. Prof. Dato has received his MD, Doctor of Medicine from USM, diploma certifications, specializations in neurosurgeries, and PhD in biomedical science from University of Ghent, Belgium. He's currently a professor in neuroscience, chief of neurosurgeons, and chairman of brain and behavior clusters of USM. He has received multiple national and international recognitions. He has been appointed as a Fellow Academy of Science, Malaysia, Royal College of Surgeons, Edinburgh, Fellow of American College of Surgeons, World Federations of Neurological Societies, just to name a few. He has received Malaysian Research Awards in 1997, National Malaysian Young Scientist Award 2000, Top Research Scientist Malaysian, Anugerah Buku Negara, and multiple Anugerah Penyelidik Cemerlang from USM. Without further ado, please welcome Prof. Datuk Jafri. Prof.
Hello, good afternoon. How are you? Can you hear me? I can't hear you. Can you hear me, Dr. Tang? Yes, okay, you can, but you're muted maybe. I would like to give a small presentation today. Thank you very much, Minggu Sains Negara, for inviting me to give this brief talk on neurotechnology. And I'll be happy to have a discussion with anyone who's interested to know further about neurotechnology. Alwani, can you upload the slides? Okay, my brief talk today is titled Neurotechnology for Wellness and Illness, what we do in USM. Can we make it into a mono slide? One slide. Alwani? One slide boleh tak? Can we go to the next slide, please? Can we move the slide?
Move dah bro. Macam slow sikit.
Okay. Buat satu slide, lepas tu move to the next slide.
Dah move dah bro, tapi macam slow sikit dia punya.
Because the screen is still on the first slide. Okay. Thank you, Alwani. As you can see here, the definition of neurotechnology is technology that has significant impact on how people think about the brain and the different facets of perception, learning, and higher order brain functions. So I think this morning from 11 onwards, you were introduced to neurotechnology. There were interesting information about neurotechnology. There was a multiple choice question or quiz on different aspects of brain and sciences and neurotechnology. So I think some of you who have been here since this morning will find it quite interesting. Can we go to the next slide? And then cuba buat one slide tu, Alwani.
Dah bro, tapi macam.
Okay, what is neurotechnology? So the term neurotechnology refers to a collection of methods and instruments that allow for the direct interaction of technological components with the nervous system. Electrodes, processors, and intellectual prostheses are examples of the technological elements that are used. They are programmed to either capture brain impulses and translate them into technology control commands, or to modify brain functions through the use of electrical or optical stimulation. Go to the next slide. Boleh gerak ke slide seterusnya?
Okay, dah gerakkan bro.
Sebab dekat skrin masih slide yang tadi tu.
Bro nampak tak?
Just the same slide, neurotechnology slide.
Sekejap saya try.
Okay, dah move dah.
Dah.
You boleh buat besar ke, Alwani? Just one slide je.
Saya dah besar.
Share 1, 2, 3 sebelah kiri tu.
Saya besarkan dah, tapi dia macam. Dia macam tak boleh yang besar.
As you can see in this slide, the type of neurotechnology that we have in USM is from electroencephalography right at the top, as you can see here. And then we have to your left is the eye tracking equipment that looks at the movement of the eyes. which are tracked in the participants present with stimuli. For example, when we look at advertisements, we can look at the type of advertisements we have, and the eye tracking will tell us whether our brain is interested in that advertisement or not. To the right, you see a MEG, or better known as a magneto-electroencephalography. It records magnetic fields produced by electrical currents occurring naturally in the brain, but these currents are detected using magnetic technology and magnetic fields. TMS, or better called as transmagnetic stimulation. We use this in our hospital. It is guided by the magnetic resonance imaging, and also with tracks that we can see on the brain images. And you will see they use intense electric current to flow by a coil placed on the participant's scalp. So we don't operate the patient or whatever. We create a magnetic field that induces the current flow to flow through the cortical tissue, the brain tissue, and this follow the cortical tracks to your arms and legs, for example, or to your area of the brain that talks, that speak, or to your eyeballs and all that, so that we can see that there are stimulation so that the patient will improve, especially stroke patients or patients who have got Parkinson's disease, Alzheimer's disease, children with autistic or learning disorder. So this transcranial magnetic stimulation is quite helpful. Awani, can we go back to the slide? Slide tadi?
Yeah. Wait, Prof. Wait.
Okay. Okay, thank you. Oops, this slide. Okay. Another thing that we do, this is electrocorticography, that we place electrodes directly in the brain or on the surface of the brain. So during brain surgery, we put these electrodes into the brain, and then we are able to monitor the brain functions, as sometimes the patients are awake during surgery. Okay, and then we have FNIRS. This is available in Universiti Teknologi PETRONAS, where they can measure brain activity by detecting changes in the blood flow. The fMRI is a very common tool used in many hospitals in Malaysia, and also for research. So we neurosurgeon, neuroscientists, and other neuroscientists in our department, we use this to measure brain activity by detecting the changes in the blood flow and in the brain. As you can see, your quiz just now was asking about the blood flow in the brain. So the blood flow in the brain is the blood flow in the astrocytes. So when we are thinking about something, there's always blood flow in certain areas of the brain, and we're able to measure that. Okay, and next slide, please. Okay, so how neurotechnology reads the brain? So the brain has got billions of neurons, and these neurons have come out with an action potential, and this action potential is a minute, we say minus 17 Tesla brain signal, which is amplified by the technology, and we amplify the neuron electrical signal, and then this can be measured either by using the EEG with the help of the amplifier, or because the neurons and the astrocytes around them consume oxygen, so there is a lot of use of oxygen, and this is how we use fMRI, Bowl signal, to look at the blood flow and also the oxygen consumption. And the magnetic field for electrical signals are those that we can use with the magnetic electroencephalography to measure the electrical signals, to see the signals coming from one part of the brain to the other part of the brain. Okay, next slide, please. So this is the famous neuron. Everybody knows the famous neuron. People in secondary school, in primary school, must have learned at least 1 or 2 pages on neurons. So this neuron, as you see, has a body and has a tail. It looks like it's called an axon. and it has feet or claws. So these are synaptic terminals. So this neuron comes in different shape. This is a classical shape of one neuron. Next slide, please. So you see, next slide, yeah. So you see other neurons, they have different shapes. They are unipolar, they can be bipolar, they can be pseudo-unipolar and multipolar. And this because these neurons are in different parts of the brain, from the retina, to in the eyeball, to the frontal lobe, to the temporal lobe, to the brain stem, and they all are shaped differently. Next slide, please. So you see that the neurons cannot survive with other people. Like in Malaysia, we cannot survive alone. We are a multiracial country. We help each other. So the neurons are helped by other cells. There are the supporting cells called the astrocytes. They feed the neurons. The neurons is like a big boss. So the astrocytes give food. They are bodyguards to the neurons, and then there are supporting cells called microglial cells, and the oligodendrocyte cells, and these cells all work closely with each other, and without the help of the other cells, these cells will not be able to function. Next slide, please. Okay, so you will see that the neuronal action potential, you will see that the cell body is big with the tail called the axon, and the terminal buttons, which is like your toes. So you have this electrical action potential, which is in minus millivolt. So this is a very important phenomenon, because when the cell dies, we lose this electrical capability, and this is how it is amplified, and then we are able to use neurotechnology to measure it and to use that even to treat diseases. Next slide. Okay, so then you get the brain waves. So this is the brain waves, the classical brain waves. There are many types of brain waves. If you Google this, you will see there's alpha, beta, gamma, theta, delta. And the good brain waves are the beta brain waves when you're awake. And then when you want to sleep, or when you want to relax, you need the slow waves. So for example, the delta, theta, and other waves are very important. Alpha waves are important when you want to relax. So this is also important in neurofeedback. So when you have too much beta wave, it's not good. You want to slow your brain. You want to have less stress. So you try to decrease the number of hertz, from 13 to 32 hertz to 8 to 13 hertz, for example. Next slide. Then this is the classical fMRI. You will see the pictures of the brain. You see what is on your screen, orangish or reddish, is the blood flow. So the bold signals will tell you when you're thinking about something, you're talking, you're listening, you're smelling. We can measure everything now with the functional MRI. Next slide. Okay, so we use neurotechnology in USM for wellness and illness. In wellness, we can improve your attention. So people who have problems, trying to read, trying to memorize, trying to balance themselves, trying to learn, neurotechnology can be used to improve. We use this in patients as well. And in diseases, we have epilepsy, traumatic brain injury, stroke, brain tumors, and Parkinson. Next slide. Okay, so this is in wellness. This is some of the equipment that we have. This is the team. We don't work. Neuroscientists and neurotechnology doesn't work alone. We have a group of people who know a little bit, and in combined forces, we are able to use EEG. You see, this is Juan Alwani holding the EEG model with the EEG cap in the model, and then the picture below is the picture of the functional magnetic resonance imaging equipment that we have in USM. Next slide. Then for illness, we treat epilepsy, traumatic brain injury. So when we have epilepsy, we put this patient in the MEG machine. We monitor which brain waves are abnormal, and that guides us into how we do the operation. And then below here is the transcranial magnetic stimulation. So we know which area of the brain can be stimulated, so that there is improved in function of the arm and leg, or in memory, or in attention. Next slide. Okay, this is a brief video showing us, this is Hazim, Omar, and Rida, our PhD students. So this is briefly trying to show to you how we put the cap. So this cap is a very painless procedure. Nobody is crying. Everybody seems to be smiling here. So it's a painless procedure. So water or saline is being injected so that the electrical contact between the scalp and the electrodes are good. It's called impedance. So with this, you're able then to, when he is thinking, we give him tasks or procedures so that we're able to see him, think as well. And then afterwards, we will go slowly. This is, he's wearing the spectacles. This spectacle is not normal spectacle. This is the eye EEG tracking. So we combine EEG and eye tracking, and we can do this in neuromarketing, where let's say you make an advertisement, or you're trying to sell a product, or you're trying to design something, and you want to know whether the clients like what is being designed. So this is what we can do. So this is just using a small handphone now. We don't need big giant gadgets. So very cost effective neurotechnology, and this can help the small medium enterprise or industry in Malaysia to create design products, to package products, the right words, the right music, the right sounds, can sell lots of things. But that's in the wellness part. In the illness part also, we can do rehabilitation with this, because when we know how people look and think, we will be able to train them to look and focus on certain objects. So this is part, of course, of neurohabilitation. So these are done with people with strokes and all that. Next video. Okay, this is an fMRI machine. So this is Hazim Omar putting the coil, onto the reader who's going into the machine, and there are tasks that they will ask reader to do and to read. As you go into the fMRI machine, you want to make sure that you're not wearing any metallic components, because that's very important, because this is a magnetic machine. So anything that uses that is iron will stick to the magnet coil. So we don't want that to happen. So you will see that at the back, there is a television or a small screen that shows the images or the sound or whatever that we want the subject or client to look and see. And then he will be thinking about it, or he's asked to press a pedal or a joystick, and give a response, so that he can the fMRI will be able to read the mind of the subject. So in this case, it's looking at the spoon, looking at a picture of a scissors, so that you will find the picture of the scissors imparted on the brain. It doesn't look like a scissors, but you will see a blood flow in the area, especially in different parts of the brain, that tells us what is going on with his brain. We collect the data and we are able to analyze the data. Alwani, can we go to the other video, the third video? Okay, this is the MEG, very expensive equipment. It's about 18 million ringgit, so this 18 million ringgit will be able to measure brain waves. It uses magnetic source, and then you're able to read the brain waves from front and back. There's also a smaller version for children, even for babies, that we don't have in Malaysia. But I think the closest would be in Singapore, where they have bought a machine that you can do children as well. So this machine will tell us whether there's abnormal waveforms, and this will help us to treat patients with epilepsy, for example. So they're abnormal waveforms, and then we can treat them by medication. If needed, we treat them by surgery, for example. And we can do this also to do neuromarketing studies and other studies as well. This is a more expensive version of an EEG. So we can do neuromarketing with this equipment. We can do other attention training, perception training. So this is something that we have been doing since the last, I think, 9 years in USM. Next slide. Alwani? Okay, I think that's all. Thank you very much. So thank you for listening to us and my talk about neurotechnology UC Science Malaysia. So I'm open for questions. Thank you. Over to you, Dr. Tang.
Thank you, Prof. Dato. Excellent talks about neurotechnologies. I think that we are now okay. So First question, how far are we with prosthetics neurotechnology?
Okay, in USM, since the last 9 years, we have been doing this prosthetic neurotechnology research with our friends from the electrical engineering school. So what is the patient or the subject has a EEG on his head, and he has a paralyzed arm, for example. So the EEG, the paralyzed arm, is attached to this exoskeleton, and when the patient thinks, the exoskeleton will move up and down, flexion, extension, for example, of the arm. At the moment, it's all at research. We haven't gone to commercialism yet. So we have no capability at the moment because we need bigger funds to move our Malaysian technology from our lab to business or to enterprise. So our prosthesis neurotechnology is good for the hand. We haven't done much for the leg yet, you know. But to compare us with Malaysia with, for example, a country like Japan, I think we are still far away. Honestly, yeah.
Thank you. I think that we have another question. I think that this is last question due to time constraint. Just curious, can this technology identify and verify headaches caused by migraine?
Okay, we will say that it's the reverse. It's like migraine is a diagnosis, and the differential diagnosis of migraine can be an aneurysm or abnormal blood vessel. So the imaging technology like MRI and other machines like cerebral angiography can be used, not EEG, but these imaging machines can be used to visualize the blood vessels in your brain. And that can see whether you have any problems with the vasculature of your brain. And if that is normal, then maybe you have migraine, maybe. Then there are, of course, other causes of headache, which is not only migraine, but can be other sources as well.
Right. Thank you very much. I think that we're really grateful to Prof. Dato from taking time out from very busy schedules and still willing to share with us. I think that we have a lot more questions.
Yes.
But I think that we have to proceed. So thank you very much, Prof, for taking time out.
Thank
I
you.
think that I will send to you all the other questions. Perhaps you can answer the questions
I will
at
answer
a
them
later.
by email.
That's correct. Thank you very much. Thank you, Prof.
Thank you.
Dato. Bye.
Bye.
So that's our first very exciting talks. Next, we have Professor Dr. Esther Gunasali, anak perempuan Ebenezer. Prof. Esther is a close friend. We work together through Dementia Para. Prof. Esther received her bachelor degrees in chemistry from Madurai Universities, MBBS from Madras University, a master in psychology medicine from She's currently a full professor in psychiatry at Royal College of Medicine, Perak, UKL. She's a fellow in old age psychiatry and an expert in evidence-based medicines in dementia and old age depression. Multiple clinical trials related to schizophrenia and received awards on her innovations. One of the main attributes of Prof. Esther is commitments to community services and is currently the chairperson of Dementia Para. Without further ado, I would like to welcome Prof. Esther for her talk.
The entire screen. Yeah, it's not coming.
So, Prof. Esther, can you share your slides?
Okay, I'm sharing my screen. Okay, I do again from the beginning. So here, I share the screen. I share the screen. Video file or just share the screen and share screen works. Share screen. Share audio, yes. Then enter. Click share is not coming up there. Entire screen. It's not coming.
So you click the
Okay. So now I can. Am I sharing correctly?
Yeah, that's correct. That's correct.
Okay, yeah. Okay, thank you. So I'm not used to this technology things. Okay, thank you so much, Dr. Tang, for inviting for the Science Week Malaysia. I'm very much glad to be a part of this program. Now I will be talking about how we are using the functional near-infrared spectroscopy in Alzheimer's disease. My previous speaker, Dr. Jeffrey, had extensive work in different part of the gadgets and technologies. Now I will be focusing only towards the functional near-infrared spectroscopy. I think you all had some quiz about this machine, and this talk is all about this functional near-infrared spectroscopy. Okay, so my talk about today will be covering aging nation, because very much related to dementia, about dementia, how the continuum of dementia, and what are the uses of functional near-infrared spectroscopy in Alzheimer's disease. Okay, so coming to aging nation, I think all of us should understand our nation. Okay, so in 2020, or just we are 21 now, you can see the amount of young old. The blue color is the young old, middle old is a red color, the green color is the old. So we do have a number of young old and compared to the old, and you see another 20 years down the road, the old and the middle old are becoming more and more. Why is it so important? Because Alzheimer's disease or any form of dementia is related to aging. The older you are, the higher chance of you getting and of the disease. Okay, so this is source that is I got from Universiti Putra Malaysia Institute Gerontology. This all our states, among all the states in Malaysia, Perak is the state with greatest number of older people. About 15% of the people living in Perak are 60 years and above. Next comes Pulau Pinang. Yeah, so it is most important and it's very relevant that we have to be prepared for the aging nation, and we are slowly progressing. Okay, dementia is a common condition in older people. If you're 65 to 69 years old, you have 1 in 100% chance of getting the disease. At the same time, if you can see 80 years and above, 1 in 6 will get the disease. So what is the ultimate inference about this? The older you are, the higher chance of you getting the disease. So what is found all around the world, for every 2 people with dementia, there is 1 man 2:1. Yeah, there are 2 women but 1 man. That means all around the world, the women outlive the men. Men die earlier than women. There are many factors why. I think because of the lack of time, I'm not going to go into that deep reasons why women outlive men. Okay, now I'll talk about a little bit of dementia so that we know what is dementia before we go into the uses of apneas in Alzheimer's disease. Okay, so dementia is a term to describe a set of symptoms which include memory loss, mood changes, problem with communication, reasoning, carrying out executive functioning. Okay, dementia is not a part of normal aging, but it is caused by disease of the brain, the most common being Alzheimer's disease. So what is happening in Alzheimer's disease patients? Okay, I'm not going to go into neuron because Dr. Jeffrey has very good, he explained in detail about neuron and the function and various different type of neurons. So I go into the pathology. What is happening in Alzheimer's disease? You know, we have trillions and trillions of neurons. So there are two pathologies, two problems happening in the brain of Alzheimer's disease. One pathology is outside the neuron. I think you all can remember. This is the neuron. So the pathology is happening outside this neuron. That is called A beta protein pathology or amyloid plaques, where this is an insoluble protein, cannot be going out of the brain through the blood-brain barrier. So they get deposited outside the neuron and it kills the neuron from outside. So what happens? The neuron dies. So it's a picture of this is diseased neuron where the A beta protein, the amyloid plaques from outside kills the neuron. This is the normal neuron. So another pathology is happening within the neuron where the neurons are many fibers, many tangles, many dendrites. So they have a lot of fibers around. Within the axons and dendrites, they have the tubules called microtubules. They are placed in very nice position, not attached to one another, by using a molecule called tau protein. So this molecule stabilizes the microtubules within the neuronal cell. But when the disease happens in Alzheimer's disease, there will be a problem with the tau protein where the nerves, all the fibers, the axons and dendrites will become fibrosed. They cannot pass information, as you can imagine, fiber optic tube where they are going in and out information, so they cannot pass information. So eventually the nerves die from inside. So these are the two pathologies that is happening in the brain of Alzheimer's disease. I'll show you a video. It is only 3 minutes video, but gives you a lot of information about Alzheimer's disease in a nutshell of 3 minutes.
What is Alzheimer's disease? Alzheimer's is a slow, fatal disease of the brain affecting 1 in 10 people over the age of 65. No one is immune. The disease comes on gradually as 2 abnormal protein fragments called plaques and tangles accumulate in the brain and kill brain cells. They start here in the hippocampus, the part of the brain where memories are first formed. Over many years' time, the plaques and tangles slowly destroy the hippocampus, and it becomes harder and harder to form new memories. Simple recollections from a few hours or days ago that the rest of us might take for granted are just not there. After that, more plaques and tangles spread into different regions of the brain, killing cells and compromising function wherever they go. This spreading around is what causes the different stages of Alzheimer's. From the hippocampus, the disease spreads here to the region of the brain where language is processed. When that happens, it gets tougher and tougher to find the right word. Next, the disease creeps toward the front of the brain, where logical thought takes place. Very gradually, a person begins to lose the ability to solve problems, grasp concepts, and make plans. Next, the plaques and tangles invade the part of the brain where emotions are regulated. When this happens, the patient gradually loses control over moods and feelings. After that, the disease moves to where the brain makes sense of things it sees, hears, and smells. In this stage, Alzheimer's wreaks havoc on a person's senses and can spark hallucinations. Eventually, the plaques and tangles erase a person's oldest and most precious memories, which are stored here in the back of the brain. Near the end, the disease compromises a person's balance and coordination. And in the very last stage, it destroys the part of the brain that regulates breathing and the heart.
Okay, so this is how the disease progressed over the years. So normally we use the scale called mini mental state examination. It is widely used all around the world to monitor the progress of the disease and also to monitor the efficacy of medicine, that we give some medication for memory problem. So we use this scale to assess whether the medication is working or not. So in the mild, the MMSE mini mental state examination they'll be scoring 20 to 24 out of 30. Then slowly in moderate stage, the score goes down. In severe stage, the score goes down further. So at the beginning stage, the instrumental activities of daily living will be affected. As the disease progresses, the basic activities of daily living will be affected. And towards the end, they can't take care of themselves. Somebody has to care for them. So this is the dementia progression. Okay, now we come to the major part of the talk today, FNIAS in Alzheimer's disease. Okay, so we did research with the Universiti Teknologi PETRONAS and together with the University Kuala Lumpur, Royal College of Medicine, Perak. So we had good collaboration between both the universities, and we are carrying out some research activities with FNIAS. So this is one of our early research program where we wanted to find out the compensatory mechanism in the brain using the prefrontal oxygenation. That means front part of the brain, how the oxygen is using when the person is doing some activities. So this to see whether the brain is working, how the brain is working when the person is subjected to some activities. So we did a comparative study with healthy control, that means they are healthy, not having any problem with memory, mild cognitive impairment and mild Alzheimer's disease. So there is a gray area between healthy people and mild Alzheimer's disease. So in between is a very gray area. They have some memory problem, but not so much affecting their functioning level. So we are not really sure whether we should start treatment or not. Yeah, but basically medication is not indicated for mild cognitive impairment. So what else we can be done for people with mild cognitive impairment? So our research is mostly, we focused on this, as I told you, mild cognitive impairment. There is memory loss, but it is not so severe enough to cause impairment in functioning, and mild Alzheimer's disease, and we compare with the normal control people. So all our researches are based on this three group of people. Okay, so we did complete the research and it was published in Frontiers in Aging Neuroscience in 2017. And the aim of the study is to differentiate the difference between mild cognitive impairment and Alzheimer's disease, mild Alzheimer's disease, using the prefrontal cortex, that is the front part of the brain, how activation is happening. And we can take that as a compensatory activity of the brain, and to investigate how is the degree of hyperactivation. Is it a little bit activated or is it a lot activated in patients with mild cognitive impairment and Alzheimer's disease compared to normal people. Okay, so the participants were right-handed because they have to use the mouse, and we took people with mild cognitive impairment, mild Alzheimer's disease and normal. They were all matched for their gender, the age and education. And as I told you before, we had mini mental state examination to assess their progress. And also the research was being approved by our medical ethics committee. Okay, so this is the method of using the probe. This is FNIAS, where the red colored dots are the source, where the blue colored dots are the detector. In between the source and the detector is the measuring channel. So we have 52 measuring channel. That is sufficient enough to measure all the brain activities. Most of the brain activities will be measured by using this 52 channel probes. Okay, here I'm just giving you a video to show how the words are very important. Word finding difficulty is one of the major symptoms, and it could be the early symptom also, it could be. So you'll be amazed why this person could play a guitar. I'll show you now. Very well.
No New Year's Day to celebrate. New Year's Day, I just called to say I just called to say I just called to say I love you. And I mean it from the bottom of my
Okay, this is a simple illustration where the person can play guitar, but the words of the song doesn't come. So very often people with memory problem, with dementia, they have problem with word finding difficulties. The right word doesn't come out. You'll be surprised why the person can play guitar very well, because it is a procedural memory. Procedural memory can retain long. Even you must have read from newspaper where a person drives the car, got lost the way. So they can still drive even though they are demented, but they can get lost. Why we took the words semantic memory. We use fruits, food, and animal. So in this experiment, patients will be resting for 20 seconds, and they are given 60 seconds to come out with fruits, different number of fruits, as many as they can within a minute. Then they are given 20-minute rest, and they are given another 1 minute to come out with different type of food. And again they are given a rest, and they should come out with different number of animals as much as they can within 1 minute. So these are analyzed and how the brain has been functioning while they are doing this activity. So what has been shown, you can see the white color is the normal control people, gray is the mild cognitive impairment people, and the black is the mild dementia patients. So you can see the activation time, it is more in the mild cognitive impairment group. That means they're really working very hard to get the task done with the words. What are the words supposed to come out? So if you can see this here, this is on the left prefrontal cortex. On the right prefrontal cortex, you can see the difference between the Alzheimer's patient and the mild cognitive impairment patient. The activation slope is very much significantly different. So what has been concluded, the time taken and the activation slope were a good indicator or parameters to measure the neurocompensatory mechanism. What it says, the mild cognitive impairment really working very hard to compensate for the loss in order to produce that number of words. Okay, so here you can see the same oxygenation, how it is measured in the FNIAS can measure the oxygen in the brain while some activities are going on. So you can see in mild cognitive impairment, the red color is the oxygenated hemoglobin, the blue color is deoxygenated hemoglobin. You can see the concentration of oxygenated hemoglobin becoming much higher in the Alzheimer's mild cognitive impairment patient, whereas in the normal people, the amount of oxygen used is not that much compared to mild cognitive impairment. Finally, if mild Alzheimer's disease, the oxygen consumption is even lesser. So what has been found? Higher oxygenation has been found in the concentration is being found in the mild cognitive impairment, followed by healthy control, and followed by Alzheimer's disease. So this is same thing had happened even at the left side of the brain and also at the right side of the brain. Similar pattern was observed. Okay, so what we come to the conclusion, faster hemodynamic response is seen on the right prefrontal cortex in the Alzheimer's, in the mild cognitive patients as a form of compensatory mechanism, and we have found the similar findings where the people with mild Alzheimer's disease, they have poor performance in the verbal fluency test, and the activation slope is smaller, and they have loss of compensatory activity and reduced amount of oxygen utilization compared to healthy control and mild cognitive impairment. So why is it happening this way? Because the conclusion is people with mild Alzheimer's, the brain is already damaged because of neurodegeneration, the nerve cells died, so that they are not able to compensate. Whereas in normal healthy control, the brains are healthy, everything is going on normal, so they no need to put extra effort to produce or to remember the numbers, the verbal fluency test, the words that are supposed to remember as many as possible. Whereas in mild cognitive impairment people, they are in between both, and they have to really work hard to produce that number of words that is required within 1 minute. Okay, so the other, yeah.
I think that due to the time constraints, I think that we can we take one question? One is dementia curable at this stage?
Okay, shall I just run through a little bit? Okay, just finishing. The other thing we did with the semantic, we also published where the visual memory test is done, where the patients have to remember different type of pictures and they were given retention and they're supposed to retrieve. Finally, they were supposed to retrieve. So the level 1, level 2, level 3. So level 2 and 3 will be difficult. So people with mild cognitive impairment did use the oxygen a lot in level 2 and 3. That means it tells how mild cognitive impairment people are using more amount of oxygen. These people with mild cognitive impairment, level 2 and level 3, compared to other group of people, they don't show that changes. Okay. Right, so I'm not going to go to this. And then finally, we are currently doing whether FNIAS can be useful to train Alzheimer's patient to remember better. That is our objective. So where the patients are supposed to come and do cognitive training twice a week for 3 months, and we see the outcome of the activities, whether there are improvement in the brain function. And whatever the activities done, they will be measured in the brain as FNIAS, and we will come out with some measurement. So this is what is done FNIAS, where the patients are supposed to do mental. And the machine, this is FNIA machine, it will measure the amount of oxygen utilization and various other parameters to see how the brain is functioning. And this is how it is done. So all will be captured in the brain. So next, they also see how synchronous patients can do the left hand and right hand, and all the parameters will be measured in the FNIAS. Okay, this is about how the color and the word. So the word is different, the color is different. Okay, so far we have done only 2 control, that means normal people with Alzheimer's, but they didn't go for training 2 times a week. And we have 15 people who went through training, that is in intervention group, 2 times a week for 3 months, and they have come out with some very few data, not enough to come to a conclusion, but with a small number of data, we have found that those who are doing training are doing better compared to those people on the control in various mini mental state examination, digit span, coding, and matrix reasoning. So they are doing better, but we need more people more number of clients, patients to go for this research to come to a proper conclusion. Okay, so with that, I thank you. All right, so maybe any questions I can answer here?
Yeah, Prof. Esther, thank you for wonderful talks. I think that we have a better understanding about dementia. I think that we have a question here by Mr. Gu. He asked that is dementia curable?
At the moment, it is not curable because there are a lot of research going on for disease modifying agent. There is no such disease modifying agent. What we have is just for symptomatic treatment. The person having problem with memory, because there is a chemical called acetylcholine transmit. Acetylcholine is the important neurotransmitter that is important for memory. So the medication, whatever we are having, it will increase the acetylcholine by some mechanism. That's all. But there is no medication or no vaccines. At the moment, they are still working on the vaccines to stop the A beta protein pathology that I mentioned to you, to stop the tau protein pathology that I mentioned to you. So these are the two main pathology that is happening in the brain. Until today, there is no cure found for Alzheimer's disease or for dementia. But we have medicine to prolong the illness so that they can have a better quality of life, they can be more independent, so the disease can be slowed down by taking the medication at an early stage.
Right. Thanks for the explanations. I think that please do feel continues to send in your questions in the YouTubes. I think that Prof. Estes will answer it after the sessions. Thank you very much, Prof. Estes.
Okay, thank you.
Take the time and so on. Yeah.
Okay, thank you.
Thank you. So next, thanks for your patience, and then we have our third speaker, Dr. Nasrin. Dr. Nasrin receives a Bachelor Engineering degree from IT, MSc in Electrical and Computer Engineering from Kini University, and PhD from University. She is currently an associate professor at Electrical and Electronics Engineering. She is immediate past chair of IEEE Women in Engineering Malaysia section, and she's a strong advocate for STEM program. She's an expert in signal processing, and the current research interest is designing framework to process and analyze brain signals. Without further ado, please welcome Dr. Nasrin.
Thank you, Dr. Tang, for that introduction. I hope you can hear me.
Yeah.
Okay. Hi, I am Associate Professor Dr. Nasrin Badruddin, and I am from the Department of Electrical and Electronic Engineering, Universiti Teknologi PETRONAS, as well as being attached to the Institute of Health and Analytics at UTP. I would like to thank the organizers for inviting me to give a talk in this event. Now, you may be wondering why a person whose background is electronic engineering would be working in neurotechnology. And I hope that in my presentation today, I'm able to show you how engineering, specifically electrical and electronic engineering, is actually very closely related to the human brain. So what is engineering? Let's start off with the definition of engineering. Now, there are many definitions out there, but the one I like is this one. So engineering is the practical application of science and mathematics to solve problems by designing and building things. Now, when you think of what engineers have built or designed, things that come to mind would include structures like bridges, transportation systems, circuits, computers, computer programs, as well as processing plants. Now, in fact, the job scope of the different disciplines of engineering has its counterpart in the human body. So let's look at some of the systems that are in our body. Here I have 3 examples here. We have the skeletal system. We have joints that allow us to move some parts of our body, and the digestive system. Now, if an engineer were to design the skeletal system in the human body, the engineer that would have to do this would be a civil engineer. Now, actually, when people think of the word engineer, the first image that comes into mind is the engineer who works in construction sites, who wears hard hats. Okay, so those are the civil engineers who design and build structures, including the frames that hold up a building. Now, when it comes to movable parts like joints and so on, we need to give the job to mechanical engineers. Oops. Mechanical engineers. Now, civil engineers must make sure that things don't move. On the other hand, mechanical engineers must make sure that things move. And usually we associate machines that have motion or movement with mechanical engineers, such as the robotic arm. Let's now look at the digestive system. Okay. Now, the digestive system consists of a series of chemical reactions or processes that help us digest the food that we eat. Now, the engineers that would design processes involving chemical reactions are called chemical engineers. Now, chemical engineers should not be confused with chemists who work with the chemistry of things. Chemical engineers, in fact, design chemical processes, not necessarily the chemicals. So lastly comes the question, where do electrical and electronic engineers come in? Now, when we think of electrical engineers, people usually associate us with electricity, electrical power generation, and electrical power lines. Okay. What many people do not know is that EE engineers not only work with electrical power, but we also work with electrical signals. Now, where do we find electricals in our body? Actually, electrical signals are used to control many functions in the body. So the commands would come from, you guessed it, the brain. So in fact, many of the things that the brain does have its equivalent device designed by EE engineers, such as brains are used for control things as well as making decisions. And EE engineers are responsible for designing control systems and controllers. The brain is responsible for doing mental arithmetic tasks such as calculation and computation. And EE engineers are also the ones who design the simple calculator and more advanced computers. We also have the brain is responsible for us communicating with other people. So communication devices such as the telephone is actually designed by electrical and electronic engineers. And another function, for example, recognizing things. We are able to recognize between different things. For example, the difference between a cat and a dog, or different colors. That kind of technique, or object recognition or pattern recognition, is being used in computer vision. So here's an example of, for example, detecting the color yellow in a digital image. So the next question I want to ask is, how can brain signals be used to advance technology? So I'm now going to talk about the type of work I have been involved in related to brain signals. Now, one of the ways that brain signals can be used is to detect drowsiness. Now, drowsiness is a big problem on the Malaysian roads, where we can see almost every week many news reports of accidents or road accidents caused by drowsy drivers. So the question is it possible to detect when a person is drowsy by looking at its brain signal or the person's brain signals? And the answer is yes. Now, scientists have found that there is a difference between the EEG of a person who is awake and a person who is exhibiting drowsiness. So here are some, okay, so the next question is, what is EEG? I know from the previous presentations, we have been seeing words like EEG, MEG, FNIRS, and so on, but some of you may not be familiar with these technologies. So I'll just concentrate on EEG. Now, EEG is actually a method to measure electrical signals from the brain using electrodes placed on the scalp of a person. Okay, so here I have some examples of different caps that have been designed for the purpose of collecting EEG. Some of them can enclose the entire head. Some of them can only take signals from certain parts of the head. So we have all kinds of designs for EEG caps. So the question is, so what's the point of looking at the EEG signal to detect whether a person is drowsy or not? Now, if we are able to do that, then we can create systems that can prevent accidents. For example, the dashboard of the car can give a warning to the driver saying that, okay, you're actually exhibiting signs of drowsiness, you should stop and take a rest or take coffee or something, okay? But most of the time, the drivers themselves know that they're drowsy, but they don't want to stop. So another way of preventing is probably to take control of the car. Now that we have autonomous driving, it is possible to integrate the technology from EEG with the autonomous car such that if the person has if drowsiness is detected in the driver, the car automatically takes control and performs the driving or stops somewhere, okay? Or if you're creative and you want to think outside of the box, you can invent something like this, okay? Where we have, this is actual news. I did not make this up. So somebody in Indonesia has actually proposed a system which pinches the butt of drowsy drivers to wake them up. Okay, the other application I want to show you is the other work I have been working on, which is related to stress. Now, stress, depression, and anxiety is actually a very serious problem in Malaysia. Now, based on the National Health and Morbidity Survey in 2019, 2.3% among Malaysian adults actually suffer from depression. Now, 2.3% may seem like a small number, but that's about 500,000 of the Malaysian population. And stress does not only affect adults, it also affects children and adolescents. So here's another statistics from this another survey, I think in 2017, showing that actually there is a problem with the mental health of adolescents in Malaysia. Now, usually stress is determined based on questionnaires or interviews or assessments by experts such as a psychiatrist. Now, however, this relies on the response from the patients. It is possible that someone wants to hide the fact that they are suffering from these mental issues because of stigma and so on. So we might not be able to evaluate properly whether a person is suffering from stress, depression, and anxiety. So it has been found that actually EEG can also be used as a tool to assess stress. So there's also a difference between the EEG signal of a person who is under stress and a person who is calm, right? So knowing that, what can we do with that kind of information? We can we can use EEG, therefore, as a tool to assess whether, for example, in the workplace, are there factors in the workplace that causes stress? Now, here's an infographic showing the different stresses that are available in the workplace, including things like salary, long working hours, even the way the working environment is physically designed or arranged can actually cause stress to the employee. Now, when we understand stress better through tools like EEG, then that can help us to either do treatment or give intervention, or in the case of the employers themselves, they can then find ways to make sure that their employees do not suffer from stress in the workplace. And here I've shown some examples of ways that employers can work in order to make the workplace a less stressful environment for their employees. Okay, That's it. It's a very short presentation, but I hope that my very short presentation has given you some idea on how engineering and medical and health sciences can work together to improve the well-being of the society. Thank you very much. So I'm open to any question.
Thank you, Dr. Nasrin. What wonderful talk on the sharings on how engineers can help in contributing to neurotechnologies. Here, I think that there's some questions about whether car drivers could wear helmets with EEG to detect drowsiness.
That is a very good question. Actually, one of the things that is sort of the limitation of EEG right now is the fact that I've shown you the cap. It looks very intimidating, especially the ones which is fully enclosing the head. Who wants to wear that while they are driving, right? So we need to work hand in hand, not just identifying whether EEG signals can be used to detect drowsiness. At the same time, designers of the EEG technology itself must come up with new ways of making the EEG cap more comfortable. I think I've shown an example where you have the wireless type of cap which does not enclose the entire head. And also it is possible to not use all the electrodes. So it is possible to just use 2 electrodes in certain positions of the head to detect drowsiness. So even though I showed the cap which captures all the signals around the head, we don't necessarily need to use all the electrodes.
Thank you for the answers. So, okay, there's a question on how safe is the use of EEG on children? If you want to understand the emergent readers make sense of words.
Okay. I think people always they're afraid of putting things on their head or their body is because they think that the electrodes actually transmit things or emit things into the body, right? But actually, EEG does not actually put any signal into the brain. It just collects. So anything, any data or signal comes from the brain. So it goes from the brain into the electrode and not from the electrode into the brain. So in fact, we have even caps for babies and neonates. So it's pretty safe in terms of is it going to like are you going to be controlled by the EEG device? No, because it just collects. It doesn't emit anything.
Thank you for the explanations. I think wonderful. I think that I would like to thank Dr. Nasrin again for the wonderful talk. I think that all the viewers please continue to send in your questions. We will post the response later on in YouTube. Thank you very much. I hope you have enjoyed this 1 hour meeting with the experts. Now I return the floor to Mr. Shafiq. Thank you.
So thank you, Dr. Tang, and to all our panelists for the knowledge sharing. And we hope that we have learned and gained beneficial information. And as promised, we're going to announce the winner for the quiz that we had just done earlier. So the winners for the quizzes, for the top 3 winners are, first we have Renee Stacia Richard Mosuyun, and the second one is Nur Hidayati Miza, and the last one is Lim Lam Gai. So we will contact all the winners soon after to claim their prizes. So before we end, I would like to close this forum by thanking everyone who involved that have put their best effort and dedication in making sure that this event runs smoothly. So that's all from us, and hope to see you guys again next year. And stay safe and good afternoon, everyone.